Welcome back to the deep dive. Today, we're really getting down to basics. We're asking, how do we actually manage to build all this complex stuff around us, efficiently, reliably?
Yeah, it's a huge question, and we're using this source material construction concepts to kind of unpack the fundamental ideas.
Exactly. Our mission here is to give you the core definitions, the essential language, really. It's about building that foundation so you can properly understand how construction projects get managed.
And importantly, how they maybe could be managed better, because the source jumps right in with a pretty bold statement.
It does, doesn't it?
Definitely.
Basically says construction management isn't just some side activity, it's central. It's core to both how individual projects run and how construction companies operate overall.
Right. This integrated view is presented as, well, crucial. Crucial for actually improving the industry, not just theory for theory's sake.
So the aim of the source material we're looking at is really to equip you, the listener, with these concepts for better decision making.
That's the idea. Better decisions leading to, hopefully, more efficiency and higher quality. It's like getting the vocabulary and grammar before you write the essay.
Okay, let's start at square one then. The source talks about the built environment. It seems pretty obvious.
Yeah, it's just all the constructed facilities that exist, everything humans have built that's, fixed and permanent.
And it defines a facility specifically too.
It does. A facility is a permanent, fixed product built by us that fundamentally alters the environment it's in. A building, a bridge, that kind of thing.
So tangible, fixed structures.
Exactly. The source does mention some fuzzy edges, like maybe a long-term tented village, but the main theory focuses on the clear-cut cases, permanent structures.
Okay, so that's the facility who
Yeah.
gets the ball rolling. The source calls them the customer.
Right, the customer. They're the ones who initiate the whole process and, crucially, provide the finance for the construction actions.
And the source prefers customer over client.
Yeah, it argues client doesn't really add anything conceptually. The customer is usually the owner, but not always. Could be a major tenant commissioning a fit out, for example.
The key point being.
They're always external to the construction industry itself. They're the ones with the need. And it's important when the source says new facility, that covers big alterations and extensions too, not just building from the ground up.
Got it. Facility is the product, customer is the trigger. Now, how does a facility actually come into being? The source outlines 7 essential actions, like a roadmap.
Exactly, a sequence. These 7 actions are presented as the complete cycle for producing a facility.
Okay, step 1, preparing a brief. What does that involve?
The brief is,
Ah.
well, it's a statement of requirements. It lays out what facility is needed, but also the constraints. Money, time, safety rules, how it needs to function, performance targets, all that stuff.
And getting this right early is critical, the source suggests.
Hugely critical. It emphasizes that if the brief isn't prepared carefully, you're almost asking for disruptive, expensive design changes later on. It's where the customer really figures out what they need.
And often, this need comes from problems they're already facing.
Yeah, that's a good point. The source implies the need for the brief often arises from operational issues. It's not always some grand vision. Sometimes it's just fixing things that aren't working.
Like that hospital surgical tower example in the source, that seemed really telling. How does that illustrate the brief process?
Oh, that's a great example because it's so specific. It lists real problems.
Mm.
The operating theaters are too small for modern equipment, staff rooms are miles away from wards, energy bills are through the roof, not enough theaters, not enough lifts.
Real, tangible pain points.
Exactly. Recorded operational constraints. These things directly tell you what the new facility or the alteration needs to achieve. That's what goes into the brief. It makes the requirement crystal clear. It's not just we want a new tower. It's we need to solve these specific problems.
Okay, so the brief sets the requirements. Action 2 is preparing a design.
Right. The design is the proposed answer. It's the statement, the description of the product that should satisfy that brief.
And design has changed a lot, hasn't it? From paper to digital.
Massively. We've gone from drawings to complex electronic models, BIM building information models being a key part of that.
The complexity sounds immense.
It is. Modern designs integrate like hundreds of different technologies, and it's not one step. Design happens in stages, concept, scheme, detail, production information. BIM helps manage that complexity, evaluate resources, time, cost, spot problems, assess risks way earlier.
Then after the design, action 3.
Preparing a plan.
The plan is the how. How are we actually going to build this design? It identifies who needs to be involved, what constraints they'll work under, sets targets.
So it's more than just a schedule. Oh yeah, it can be simple, like a target budget and date. Or it can be a whole suite of documents. The project execution plan, detailed schedules, cost plans, risk assessments, quality plans, safety plans, environmental plans, who's who in the organization, even meeting structures.
Basically the rule book for getting it done.
Pretty much. It provides the framework to make sure the next steps, procurement, manufacturing, production, commissioning, all happen efficiently and actually deliver what the brief asks for. On time, on budget, to the right quality.
Okay, action 4, procurement.
Yeah.
This sounds like bringing the team and supplies together.
That's essentially it. The actions needed to select and hire the teams and to arrange for all the materials and components. But the source actually offers a bit of a critique here.
Oh, what's the issue?
It suggests that the common sort of narrow view of procurement, focusing heavily on competitive bids right after design, using really tough contracts, can actually backfire. It can lead to conflict and, maybe surprisingly, inefficiency.
Why inefficient? Seems like getting the lowest price would be efficient.
Because, the source argues, it often forces everyone to just protect their own narrow interests. It doesn't encourage thinking about the joint interest, what's best for the project overall to get built efficiently. The theory pushes for a broader view of procurement, one that sets up cooperation, not just confrontation.
Interesting. Okay, action 5 is manufacturing.
This is about actually making or providing the physical bits, the materials and components. Think concrete, steel, but increasingly it involves large, complex components made off-site, prefabrication.
Like those hospital operating theater pods you hear about.
Exactly that kind of thing.
Yeah.
Or whole plant rooms assembled in a factory. The source points out that managing the making and delivery of these complex, often custom-made components is becoming really central to project success. And there's huge potential there for efficiency gains through things like standardized modules.
Then action 6, production. This is what people usually mean by construction, right?
Yes. Typically, practitioners call this bit construction, the boots on the ground, site work. But the source uses production specifically to keep it distinct as just one of the 7 actions in the whole process. It's the act of converting those materials and components into the actual facility on site.
And this is changing too. Less traditional building, more assembly.
Definitely. There's a shift towards assembling those large prefabricated components we just talked about. So production starts to look a bit more like manufacturing itself. For a typical building, you'd still see stages like substructure, main structure, the cladding or envelope, internal fit-out, and so on.
Right. The final action, number 7, commissioning. Just the final checks.
It's way more than just checks, and the source really stresses that it's vital but often gets neglected or rushed. Commissioning involves making the facility fully functional and training the end users, the people who will actually operate it.
Ah, so not just flicking the switches, but making sure the building manager knows how the systems work.
Precisely. There's the testing part, individual systems, the whole facility, ensuring it performs as designed. But the training aspect is equally critical, according to this source.
Like in that school example, the building control system.
Perfect example from the text. A new school gets a fancy building control system, a BCS, managing heating, lighting, security, everything. The source says the biggest hurdle often isn't the tech, it's whether the school's facilities team knows how to use it properly.
They even suggest a new efficient building could use more energy if the system isn't used right.
Exactly. Which really underlines why commissioning isn't just about ticking boxes, it's testing and training. They're inseparable for the facility to actually deliver its intended benefits. And the source notes, even simple repairs involve all 7 actions, just scaled down.
Okay, that's a clear breakdown of the 7 core actions. Now let's shift focus a bit to the who and how. The organizations involved and how they interact. Let's start with defining construction and construction project.
So construction, with a capital C, in this context means all the human actions involved in making or altering facilities, the whole process.
And a construction project.
That's simply one specific instance of doing those 7 actions. It has a defined start, a defined end, a single job, basically.
But the source is quite critical of focusing only on individual projects, right? It sees weaknesses there.
Yeah, this is a really important point in the theory. It argues that a purely project-by-project approach leads to problems, like teams constantly facing new situations, which makes it hard to learn and standardize. Teams often break up after a project, so knowledge and good working relationships get lost.
Hard to justify long-term investment, too.
Exactly. Investing in serious innovation or better training or new equipment is tough to justify on just one project's budget. And the focus can easily drift to just maximizing profit on this job rather than thinking about overall long-term efficiency for the industry or the company.
Okay, so if that project-centric view has flaws, what's the alternative the source proposes for better efficiency? Construction programs.
Right. A construction program is defined as a series of separate projects that are treated as an integrated whole because they share common features, like a hospital building several similar clinics, or a retailer rolling out a standard store design.
And the advantages of thinking in terms of programs?
Several key ones highlighted. It lets teams work together repeatedly, building trust, smoothing out processes, becoming more efficient over time. It makes that long-term investment in things like training, new tech, or better processes justifiable because the payoff spreads across multiple projects.
Streamlines things, too.
Yeah, things like approvals, legal agreements, setting up supply chains can potentially be streamlined across the program. The role of construction management here is identifying those opportunities to link projects strategically and reap those benefits. And sometimes this is formalized through things like framework agreements or even mergers.
That idea of permanence teams working together over time, enabling efficiency, feels really central. We should probably come back to that. But first, the players. There's a huge variety of organizations involved in construction. How does the source categorize them?
It simplifies the landscape to make it manageable. It defines a few key types.
The basic unit.
The construction team. That's a formal group, usually permanent, with specialist skills and maybe equipment working together. The source stresses coordination, and their experience as a team is key.
And these teams belong to?
Construction companies. These are the permanent organizations that employ and support the teams. And this is broad. It includes architects, engineers, quantity surveyors, contractors, specialists, not just builders. They vary hugely in size and are often organized into divisions.
And all those companies together?
That's the construction industry.
Okay, and for a specific job?
The teams brought together for one job form the construction project organization. And if it's a program,
That's the construction program organization, linking those teams strategically across projects.
exactly. It's layers of organization. The source even uses a metaphor, like a neural network, to show how these teams, divisions, companies all link up and interact to get projects done.
What about those outside this industry definition? People who still influence things.
The external influences. The customer, obviously, is number one, unless they happen to be a developer building for themselves. But then you have government agencies, local authorities, maybe local community groups, sometimes protest groups, the media.
Especially early on.
Yeah, often early on. Later, external factors might be more like disruptions in manufacturing or transport, bad weather, industry-wide disputes, market changes, labor shortages, things outside the project team's direct control.
And the theory's approach to these.
It focuses on managing the effect of interference rather than predicting every specific source. Practitioners obviously need to know why something is delayed, but the theory aims to provide tools to manage the resulting uncertainty, whatever the cause.
Okay, let's go deeper into how these organizations actually function internally. The source says they share common characteristics, despite the variety. What are they?
Three main ones are identified. First, information, defined as useful knowledge, whether it's remembered or written down. The key part is that for knowledge to be useful organizationally, it has to convey sufficiently similar meanings to everyone using it.
So shared understanding is vital, not just data.
Absolutely. The source uses a simple example. See bricks, door, window, roof, deduce house. That shared understanding lets you make assumptions. Managing all the different knowledge held by different specialists is presented as fundamental to organizational success. Efficiency, profit, even survival depend on it.
Second characteristic.
Values. Defined simply as preferences. Organizations have values like customer focus or safety first, but the source is a bit cautious here, noting stated values aren't always the real ones, especially under pressure. Effective organizations, though, tend to show consistency between what they say they value and what they actually do.
And third?
Actions. Organizations do things. They take actions to produce construction. And importantly, the source points out actions can be intended and authorized part of the plan, or unintended and unauthorized. Things like mistakes, defects, delays, cost overruns. A key aim of the theory presented is to help managers avoid those unintended negative actions.
Right, so information, values, actions define the organizations. How do they work together? That gets us into interactions and relationships.
Exactly. A relationship in this view, is just a series of interactions over time between organizations or teams, and the source breaks down interactions into three types.
Okay, first step.
Communication, which is simply transferring information.
Yes.
But the source flags a big challenge here, differences in understanding, interpretation. It calls it prejudice, meaning pre-existing viewpoints or jargon getting in the way.
It outlines steps for effective communication.
Yeah, 5 things. The information has to exist. It's put into a medium, words, drawings, data. That medium is moved, the receiver detects it, and this is crucial, the receiver attempts to understand it, ideally achieving a common understanding. Constant checking is needed because miscommunication causes so many problems.
Okay, second type of interaction, transaction.
This is different from just communicating. A transaction involves an exchange of things that have value based on the parties' values or preferences. Think contracts, payments, agreements. It requires negotiation beforehand and involves all those formal procedures common in construction, standard forms of contract, tendering rules, etc.
So it's about exchange, not just information transfer.
Precisely. There's an expectation of return based on value.
And the third type.
Organization of coordinated actions. This is when 2 or more organizations formally agree to collaborate on specific tasks. The source says that while they are doing those actions together, they effectively form a temporary combined organizational unit for that purpose, even though they remain separate companies overall.
So interaction is either communication or transaction. And coordinating actions creates a temporary joint structure.
That's the framework laid out.
Okay, thinking about these interactions building up.
Yeah.
This leads to networks of organizations, like on a project or program. And the source introduces this idea of double-loop learning here.
Right. You can think of these construction networks as sort of self-organizing systems. Feedback is key information about how actions turned out. Rational organizations use feedback to adjust and improve.
But double-loop learning is more profound.
Yes. It describes 2 levels of learning from feedback. Loop 1 is the basic level, using feedback to get better at achieving current goals within the existing rules and norms. Adjusting course, basically.
Loop 2.
Loop 2 is more fundamental, operates over a longer time. It's when feedback causes the organization to question the underlying assumptions, the norms, the standards themselves. It can lead to completely new ways of doing things, a real step change in performance. Transformative learning.
What enables that deeper second loop learning?
The source argues it needs support from the top company strategies, established methodologies. But the single most critical factor identified is permanence.
Ah, there it is again. Teams sticking together.
Yes. Teams need to work together repeatedly on multiple projects over time. That allows them to consistently use, review, critique, and actually improve their systems and procedures. That's how double-loop learning becomes practical, not just theoretical. The source really hammers home permanence as a cornerstone for efficient construction management.
It makes sense. It directly addresses that weakness of constantly breaking up teams. Okay, let's talk about the quality of relationships between teams. The source says this has a direct impact on performance and describes a spectrum, using the terms folding and composing.
Right. These terms describe the nature of the relationship and how teams interact. At one end, you have boundary relationships, and the process is called folding. This is where teams act primarily as if they belong to different separate organizations, even when they're supposed to be collaborating.
Like working together for the first time.
Yeah.
Or from rival companies.
Exactly. Interactions tend to be very formal, transaction-heavy, based strictly on the contract. The source points out some negative tendencies here.
Such as?
Relationships can be difficult, even hostile, especially if the contract negotiation felt unfair. It takes ages to find common ground. People stick rigidly to the letter of the contract. They don't readily share information or resources unless forced. And the focus is purely on their own company's short-term profit. Sometimes they might even try to exploit problems for gain.
And this wastes time and effort.
Yeah. Figure 3.3 in the source illustrates this. A lot of energy gets burned up in managing these difficult interactions, leaving less time and fewer resources for the actual construction work. Folding is the state of acting as separate, potentially adversarial entities.
So what's the opposite end? The more positive model?
That's established or internal relationships, and the process is called composing. Here, teams act much more like they are part of a single joint organization working towards common goals.
Built on trust and past success.
Yes, typically based on successful collaboration over time. Most common, perhaps, within the same company or division, but definitely possible between different companies if they have a strong, positive history.
And the characteristics are much better.
Much better quality. There's open sharing of information, Resources are used for the joint benefit. Communication flows easily, often using shared language or understanding. Work gets allocated fairly, and crucially, teams tend to help each other out when problems arise.
Leading to better outcomes.
The source claims yes, they can start work faster, operate more efficiently because less time is wasted navigating difficult relationships. Again, Figure 3.3 contrasts this. Most effort goes into the actual construction actions. Composing is about continuously building and improving these positive collaborative ways of working.
So folding is sticking to the contract, separate interests, no real relationship building. Composing is built on established trust, shared goals, and aims for ongoing improvement. That seems like a really vital distinction for efficiency.
It really gets to a core potential problem or solution in how construction operates.
Okay, nearly there. Before we define construction management itself, the source highlights two more factors that add uncertainty and affect performance.
Yes, two big ones: performance variability and external interference.
Performance variability.
It's just the fact that human and team performance isn't perfectly consistent. It varies day to day, week to week, influenced by skill, experience, morale, how well the team communicates, crucially, how much experience they have working together.
And the source puts some numbers on this.
Yeah, it mentions variability can be something like plus or minus 50 or 60%, even on projects considered well run. If things go wrong, it gets much wider. This makes reliable planning incredibly hard and often leads to wasted resources like equipment waiting around or labor being underutilized.
A major headache for managers. And the second factor, external interference.
We touched on this earlier. It's the impact of things entirely outside the project organization's direct control. Government decisions, planning issues, media coverage, supply chain failures, weather, disputes elsewhere in the industry, economic shifts, labor availability.
Unpredictable stuff.
Very unpredictable, often. Risk management tries to buffer the project against these things, but they remain a constant source of uncertainty that managers have to grapple with.
Okay, we've covered a lot of ground, broken down these core concepts. Let's loop back and define construction management itself, according to this source, and then efficiency.
Right. Construction management within this theoretical framework is defined as taking responsibility for the performance of a construction organization. That could be a team, a project organization, a company division.
So it's about managing the performance of these organizational units.
Yes. And while everyone contributes to performance, managers have specific delegated authority and responsibility for the actions of others. It's not just about their own tasks.
And performance isn't just down to the individual teams.
No. The source stresses it's highly dependent on the competence, the structure, and crucially, the relationships within the larger organizations these teams are part of, the project organization, the program structure, the company itself. Management at those higher levels is just as critical.
And finally, how does the source define efficiency for its purposes?
It uses a specific theoretical definition here. Efficiency is seen as being inversely related to waste. And waste, in this context, is caused by two things: the inherent complexity of construction and the impact of external interference. Both of these prevent organizations from smoothly achieving their agreed objectives.
So less waste equals more efficiency.
That's the concept used to build the theory. The source acknowledges that measuring efficiency objectively is a whole other topic for later discussion.
Okay, that's quite a journey. We've gone from the basic idea of the built environment and facilities through the 7 essential actions from brief to commissioning. We've looked at the different players, teams, companies, the industry, and the external influences. We dug into what makes up these organizations: information, values, actions, and then how they interact through communication and transactions, leading to relationships that could be folding or composing, plus the importance of permanence for double loop learning and the real-world challenges of variability and interference.
It's a lot, but having this vocabulary, this framework, is really the key takeaway from this part of the source. It gives you the tools to start analyzing construction management theories and practices aimed at improving things, improving that efficiency and quality.
It really does provide a structure for thinking about it all. So for you listening, you should now have a much clearer grasp of the fundamental concepts underpinning how construction projects and the organizations doing them are viewed and managed through the lens of this particular theory.
Absolutely. And perhaps thinking about all those inherent challenges, the source lays out the complexity, the communication hurdles, the tendency towards less efficient folding relationships and typical project setups, the unpredictable external world. It leaves us with a pretty challenging final thought to ponder, doesn't it?
Which is?
Well, given all that, how can construction management in practice, day to day, actually achieve the kind of consistent efficiency, the high quality, and that deeper transformative learning that the theory suggests is possible, but seems so difficult to attain in reality?